Private satellite companies, past, present, and future. Introduction. The private satellite industry has undergone a remarkable transformation over the past few decades. From its nascent stages in the 1980s to the robust and innovative landscape of the present, private companies have increasingly become pivotal players in space exploration, satellite manufacturing, and launch services. This report delves into the historical context, current landscape, and future prospects of private satellite companies, highlighting key players and their contributions to the industry. Historical context and evolution. The early years. The private space industry began to take shape in the early 1980s with the establishment of companies like Orbital Sciences Corporation (OSC) in 1982. OSC was a pioneer in the development of launch vehicles and satellites. It gained prominence with the launch of the Pegasus rocket in 1990, which was the first privately developed space launch vehicle. OSC would later merge with Alliant Tech Systems in 2015 to form Orbital ATK, which was subsequently acquired by Northrop Grumman in 2018. Another significant player was Sierra Nevada Corporation (SNC), founded in 1963, which ventured into space technology in the 2000s. In 2021, SNC spun off its space division as Sierra Space, focusing on the development of the Dream Chaser spacecraft and the Orbital Reef commercial space station in collaboration with Blue Origin. The 2000s, expanding horizons. The 2000s marked a significant turning point for private spaceflight. SpaceX, founded by Elon Musk in 2002, revolutionized the industry with its ambitious goals and technological innovations. The successful launch of the Falcon 1 in 2008 was a landmark achievement that set the stage for future successes, including the Falcon 9 and Falcon Heavy rockets. Simultaneously, other companies began to emerge, including Blue Origin, founded by Jeff Bezos in 2000, which focused on suborbital flight and reusable rockets. The private sector's growth was fueled by government contracts, particularly NASA's Commercial Crew and Commercial Resupply Services programs, which opened opportunities for private companies to engage in space missions. Present-day landscape. Today, the private satellite industry is characterized by a diverse range of companies engaged in satellite manufacturing, launch services, and space exploration. Some of the most notable players include SpaceX. SpaceX stands out as a leader in the private satellite industry. With its Falcon 9 and Falcon Heavy rockets, SpaceX has conducted numerous satellite launches, significantly reducing launch costs through reusability. The company has also been instrumental in NASA's Commercial Crew program, transporting astronauts to the International Space Station (ISS) using the Crew Dragon spacecraft. Blue Origin. Founded by Jeff Bezos, Blue Origin is making significant strides with its New Shepard suborbital vehicle and the upcoming New Glenn rocket. The company focuses on reusability and aims to develop a sustainable space economy. Rocket Lab. Rocket Lab, established in 2006, specializes in small satellite launches with its Electron rocket. The company is well positioned in the growing small satellite market, providing cost-effective solutions for launching payloads into orbit. Sierra Space. Sierra Space is focused on developing the Dream Chaser spaceplane, which will provide cargo and crew transport services to the ISS. The company is also working on the Orbital Reef space station, aiming to create a mixed-use business park in low Earth orbit (LEO). Other notable players. Astra Space focuses on small payload launches and has been working to establish a reliable launch schedule. Relativity Space is innovating with 3D printed rockets, aiming to reduce manufacturing times and costs. Virgin Galactic, founded by Richard Branson, is focused on suborbital space tourism with its Spaceship Two vehicle. Future prospects. The future of private satellite companies appears promising. With advancements in technology and increasing demand for satellite launches, key areas of focus include reusable technology. The continued development of reusable launch vehicles will likely reduce launch costs, further making space more accessible. SpaceX's Falcon 9 has set the standard and other companies are following suit with their reusable designs. Commercial space stations. With the retirement of the ISS in the coming years, privately operated space stations like Orbital Reef are expected to play a crucial role in research tourism and manufacturing in space. These stations will provide opportunities for commercial partnerships and scientific exploration. International collaboration. As space exploration becomes a global endeavor, international collaborations will likely increase. Partnerships between private companies and governmental space agencies can lead to more ambitious projects, including lunar and Martian exploration missions. Satellite connectivity and services. The demand for satellite connectivity, especially for remote and underserved areas, is expected to rise. Companies like SpaceX with its Starlink program are working to provide global internet coverage through satellite constellations. Key differences and common points. While many private satellite companies focus on launching satellites, their strategies and technologies differ significantly. SpaceX emphasizes reusability, significantly driving down launch costs and enabling rapid launch schedules. Rocket Lab targets the small satellite market, focusing on efficient and cost-effective launches. Sierra Space and Blue Origin are investing in space infrastructure and habitability with plans for commercial space stations and advanced spacecraft. Timeline of key events. 1982, Orbital Sciences Corporation founded. 1990, Pegasus launches, marking a milestone for private spaceflight. 2015, Orbital ATK formed from the merger of Orbital Sciences and Alliant Tech Systems, later acquired by Northrop Grumman. 2021, Sierra Space established as a spin-off from Sierra Nevada Corporation. 2022, Blue Origin and Sierra Space announced the development of Orbital Reef. 2023, Sierra Space completes its first Dream Chaser vehicle, anticipated for launch in 2024. Conclusion. The private satellite industry has evolved from small experimental companies to major players in the global space economy. With ongoing advancements in technology, a focus on sustainability, and the potential for international collaboration, the future of private satellite companies is bright. As they continue to innovate and expand their capabilities, these companies will play a vital role in shaping the future of space exploration and utilization. The private satellite industry has witnessed a fascinating evolution from its inception to the present day, with significant implications for future developments. The following points highlight counterintuitive information derived from the extensive details provided. 1. Misconception of early private spaceflight. A common belief is that private spaceflight began with the advent of new technology in the 21st century, primarily attributed to companies like SpaceX. However, private initiatives trace back to the early 1980s with companies like Orbital Sciences Corporation, which launched the first privately developed space launch vehicle, Pegasus, in 1990. This early involvement contradicts the perception that significant private sector participation is a recent phenomenon. 2. Impact of mergers and acquisitions. The idea that private companies remain independent and grow organically is challenged by the history of significant mergers in the industry. For instance, Orbital Sciences Corporation, initially a pioneer in the private space sector, merged with Alliant Tech Systems in 2015 to form Orbital ATK, which was later acquired by Northrop Grumman. This pattern suggests that consolidation is prevalent, potentially limiting competition and innovation, contrary to the narrative of a burgeoning number of independent startups. 3. Reusability revolution. The assumption that rocket reusability was an entirely new concept introduced by SpaceX is misleading. The Pegasus launch vehicle, while not reusable, did showcase early innovations in launch techniques that would eventually inform later designs. However, the dramatic cost reductions achieved through reusability with SpaceX's Falcon 9 have set a new standard that earlier companies could not match, indicating that while the concept existed, the execution and impact were uniquely transformative in recent years. For public-private partnerships, there is a perception that private companies operate solely independently from government agencies. In reality, many of these companies such as Sierra Space and SpaceX have established critical partnerships with NASA and the US government, receiving significant funding and contracts that are crucial for their operations. This collaboration contradicts the notion that private firms can thrive without government support, especially in the high-stakes field of space exploration. 5. Diverse business models. Many assume that private satellite companies are focused primarily on launching satellites. However, the industry showcases a variety of business models, including satellite manufacturing, space tourism, and research-oriented missions. Companies like Blue Origin and Sierra Space are not just focused on launches but are also developing infrastructure for future space habitation and research platforms, broadening the scope of what private space companies can achieve. 6. The role of space tourism. While space tourism is often viewed as a fringe aspect of the space industry, it is proving to be a significant driver for innovation and funding. The investments made by companies like Virgin Galactic and Blue Origin into space tourism are facilitating advancements that benefit other sectors such as research and commercial satellite deployment, which counters the assumption that tourism is a distraction from more serious space endeavors. 7. Challenges of small payload launches. There is a prevailing belief that the demand for small satellite launches is a straightforward opportunity for new entrants. However, companies like Rocket Lab and Astra Space face substantial challenges in achieving reliability and consistent launch schedules in a competitive market dominated by larger players like SpaceX, which can offer more cost-effective solutions due to economies of scale. This highlights the complexity and competitive nature of the small satellite launch segment that is often oversimplified. 8. Technological leapfrogging. The growth of new entrants like Relativity Space, which focuses on 3D printed rockets, suggests that technological innovations can leapfrog traditional manufacturing methods. However, the heavy reliance on established technologies by older companies underscores that while innovation is critical, it is often built on years of foundational knowledge and experience, challenging the notion that new companies are always more innovative than their established counterparts. 9. International collaborations. Many view the private space sector as predominantly US-centric. However, the involvement of international partnerships such as those seen with Sierra Space and Blue Origin in developing the Orbital Reef space station suggests that collaboration across borders is essential in tackling complex challenges and advancing technology. This global perspective is often overlooked in discussions focused solely on domestic achievements. 10. Environmental considerations. The assumption that space launches are environmentally benign is increasingly challenged as more private companies engage in frequent launches. The environmental impact of rocket emissions and space debris is becoming a critical concern. This highlights the paradox that while the private space sector aims to democratize access to space, it must also grapple with the sustainability of its activities, contradicting the narrative that space exploration is entirely positive. In summary, the landscape of private satellite companies is shaped by a complex interplay of historical precedents, industry dynamics, collaborative efforts, and emerging technologies. The evolution of this sector reveals counterintuitive truths that challenge common assumptions about the nature and future of private spaceflight. The evolution of private satellite companies from the past to the present highlights several significant aspects that are often overlooked. Below are key points that provide insight into the importance and implications of these developments. Historical significance of early players. The establishment of companies like Orbital Sciences Corporation in 1982 marked the genesis of private spaceflight. This company paved the way for others by successfully launching the Pegasus rocket, the first privately developed launch vehicle. The significance of Orbital's pioneering efforts cannot be understated. They laid the foundation for a competitive market that we see today. Many may overlook how the early successes and challenges faced by such companies influenced current industry standards and practices in satellite technology and launch operations. This historical perspective emphasizes that the landscape of private satellite companies is built upon the lessons learned from early pioneers which continue to resonate in today's innovations. Current landscape: underestimated competition. While SpaceX and Blue Origin are often highlighted for their high-profile launches, the competition among smaller firms such as Rocket Lab and Astrospace plays a crucial role in democratizing access to space. Rocket Lab's focus on small satellite launches with their Electron rocket and Astra's commitment to establishing a reliable launch schedule for small payloads signify a shift in the market that is often overshadowed by the larger players. This competition fosters innovation and drives down costs, making space more accessible for various sectors including scientific research, telecommunications, and national security. Understanding this dynamic is vital for recognizing the broader implications of technological advancement and economic opportunity in the space sector. The future of space infrastructure. One of the most significant developments that many might overlook is the collaboration between companies like Sierra Space and Blue Origin to create the Orbital Reef, a commercial space station expected to be operational by 2027. The implications of developing a commercial space station extend far beyond mere transportation. It represents a paradigm shift towards a sustainable low Earth orbit LEO economy incorporating research, manufacturing, and potentially tourism. The establishment of such infrastructure could serve as a springboard for future deep space exploration missions, including human missions to Mars. This shift from government-led projects to private initiatives underscores the evolving nature of space exploration and the importance of public-private partnerships in achieving ambitious goals. Innovations in reusable technologies. SpaceX's pioneering work in reusable rocket technology has dramatically changed the economics of space launch services. However, innovations in reusability are not limited to SpaceX. Other companies are developing their own reusable systems, such as Sierra Space's Dream Chaser and Rocket Lab's Neutron. The significance of these advancements lies in their potential to further reduce costs and increase the frequency of launches, a crucial factor in meeting the growing demand for satellite deployments. Many may overlook the fact that the competition in reusable technology will likely lead to enhanced capabilities and lower barriers for entry into space, ultimately benefiting research and economic activities in various fields. The role of small satellites. The shift towards small satellites is another critical area that warrants attention. Companies like Planet Labs and Spire Global are utilizing small satellite constellations for Earth observation and data collection, offering services that were once the purview of larger satellites. This trend democratizes space access and provides new opportunities for data-driven applications, such as climate monitoring and disaster response. The significance of this shift lies in its potential to enable a broader array of stakeholders, including startups and academic institutions, to engage with space technology in ways that were previously unattainable due to high costs and technical barriers. International collaborations. The increasing trend of international collaborations among private satellite companies is also a significant development that may go unnoticed. Partnerships between companies across borders, such as those between U.S. firms and their counterparts in Europe and Asia, can enhance technological exchanges and broaden market access. These collaborations not only spur innovation but also create a more interconnected global space economy. The importance of fostering international relations in the space sector cannot be overstated, as it aligns with global goals for sustainability, exploration, and scientific advancement. Conclusion. The journey of private satellite companies from their inception to the present day reflects a vibrant and rapidly evolving industry. Recognizing the overlooked aspects of this evolution, from historical foundations and competitive dynamics to future infrastructure and international collaborations, provides a richer understanding of the implications for society, technology, and the economy. As the industry continues to mature, the interplay between public and private sectors will be crucial in shaping the future of space exploration and utilization. 1. Historical context and evolution of private satellite companies. Understanding the trajectory of private satellite companies from their inception to the present day is crucial. Companies like Orbital Sciences Corporation, founded in 1982, were pioneers in the space industry, developing technologies that laid the groundwork for future advancements. The evolution includes significant milestones such as the launch of the Pegasus rocket, which was the first privately developed space launch vehicle. This historical context highlights how these companies transitioned from niche players to major contributors in the space economy, paving the way for newer companies like SpaceX and Sierra Space. 2. Current landscape of private satellite companies. The present-day private satellite industry is marked by a diverse range of players, each with unique focuses and technologies. SpaceX leads with its Falcon 9 and Falcon Heavy rockets, emphasizing reusability to reduce launch costs. Other notable companies include Rocket Lab, which targets the small satellite market, and Astra Space, which aims to establish a reliable launch schedule for small payloads. This competitive landscape fosters innovation and collaboration, such as Sierra Space's partnership with Blue Origin to create the Orbital Reef space station. Understanding these dynamics is vital for analyzing how companies position themselves in the market. 3. Future prospects and innovations. The future of private satellite companies is promising, driven by advancements in technology and increased collaboration. SpaceX's ambitious Starship program aims for human missions to Mars, while Sierra Space's plans for a commercial space station by 2027 reflect the growing interest in space habitation and research. The emphasis on reusable technology and infrastructure development indicates a shift towards sustainable practices in space exploration. This section can lead to discussions about potential challenges and opportunities as the industry evolves. For impact on the global space economy, the rise of private satellite companies has significantly transformed the global space economy. These companies are not only launching satellites but are also developing technologies for exploration, space tourism, and commercial applications. The collaboration between private entities and government agencies such as NASA's Commercial Crew Program showcases the importance of public-private partnerships in advancing space initiatives. Analyzing the economic implications, including job creation, technological advancements, and international competitiveness, will provide a comprehensive view of the sector's impact on the broader economy. These 4 points serve as a foundation for in-depth analysis and discussion regarding the past, present, and future of private satellite companies, highlighting their evolution, current market dynamics, future innovations, and economic impact. 1. The launch of the Pegasus rocket, 1990. This was a landmark event in the history of private spaceflight, as it marked the first successful launch of a privately developed space launch vehicle. The Pegasus rocket was air-launched from the L-1011 carrier aircraft, successfully demonstrating the potential of private aerospace companies to contribute to space launch capabilities. This achievement by Orbital Sciences Corporation paved the way for future commercial space ventures and laid the groundwork for the burgeoning private satellite industry. 2. SpaceX's Falcon 1 launch, 2006. SpaceX's Falcon 1 became the first privately developed liquid-fueled rocket to reach orbit. The successful launch on March 24, 2006 was a significant milestone for private space companies, showcasing the feasibility of privately funded space exploration and satellite deployment. Following this success, SpaceX went on to become a dominant player in the satellite launch market, significantly reducing costs and enhancing access to space. 3. The creation of Orbital ATK, 2015. The merger of Orbital Sciences Corporation and Alliant Tech Systems to form Orbital ATK represented a significant consolidation in the private spaceflight industry. This merger combined Orbital's expertise in satellite development and launch vehicles with Alliant's strengths in defense and aerospace technology. The newly formed company continued to innovate in satellite technologies and launch services, emphasizing the importance of public-private partnerships in advancing space exploration and satellite capabilities. Future outlook, predictions for private satellite companies. The trajectory of private satellite companies reflects a rapidly evolving landscape that has seen significant advancements from its nascent stages in the 1980s to a thriving sector today. As we look to the future, several key trends and predictions emerge, shaping the potential for private satellite companies and the broader space economy. 1. Increased market competition and collaboration. The competitive landscape among private satellite companies will intensify as new entrants emerge, driven by advancements in technology and a growing demand for satellite services. Smaller companies like Rocket Lab and Astrospace will continue to carve out niches in the small satellite launch market. Simultaneously, established players like SpaceX and Blue Origin will expand their service offerings and capabilities. Collaboration will also become more prevalent as companies recognize the benefits of joint ventures. Partnerships such as the one between Sierra Space and Blue Origin for the Orbital Reef space station exemplify how companies can pool resources and expertise to tackle complex projects. This trend will likely continue, fostering innovation and reducing costs across the industry. 2. Technological advancements in satellite technology. The next decade will witness significant technological advancements in satellite design, manufacturing, and launch capabilities. The development of more efficient propulsion systems, such as those being refined by Sierra Space and other companies, will enable longer missions and improved maneuverability in space. Furthermore, the adoption of artificial intelligence (AI) and machine learning in satellite operations will enhance data processing and analysis capabilities, allowing for real-time decision-making. The rise of megaconstellations like SpaceX's Starlink and OneWeb will continue to reshape the satellite landscape. These constellations aim to provide global broadband coverage, expanding internet access to remote areas and creating new revenue streams for satellite operators. This trend will push the boundaries of satellite technology, necessitating innovations in miniaturization and mass production. 3. Focus on sustainable practices. As the space industry grows, the issue of space debris will become increasingly critical. Private satellite companies will be compelled to adopt sustainable practices to mitigate the risks associated with orbital debris. This may include the development of end-of-life disposal technologies such as deorbiting mechanisms or satellite servicing capabilities to extend the operational life of satellites. Regulatory bodies and international organizations will likely implement stricter guidelines for satellite launches and operations, promoting responsible behavior in space. Companies that prioritize sustainability will gain a competitive edge and enhance their reputation in an increasingly environmentally conscious market. 4. Expansion of commercial space stations and habitats. The future of private satellite companies will also be marked by the development of commercial space stations and habitats. Sierra Space's Orbital Reef and Axiom Space's plans for a commercial space station signify a shift towards utilizing low Earth orbit (LEO) for commercial purposes, including research, tourism, and manufacturing. As these habitats become operational, they will create new opportunities for businesses to conduct experiments, develop new technologies, and even host tourists. The commercialization of space will drive demand for satellite services, as these stations will require robust communication infrastructure and logistical support from satellite operators. 5. Emerging markets in space exploration and resource utilization. The private satellite sector will increasingly engage in space exploration and resource utilization. Companies are already making strides in lunar exploration and asteroid mining, driven by the potential for valuable resources in space. As more nations and private entities set their sights on the moon and beyond, the demand for satellite services related to navigation, communication, and data collection will surge. In particular, lunar missions will require advanced satellite systems to support communication between Earth and lunar bases, as well as for navigation and scientific research. The potential for in situ resource utilization (ISRU) on the Moon and Mars will further drive the need for satellites capable of monitoring and managing these resources. 6. Integration of advanced data analytics and services. Data analytics will play a pivotal role in the future of private satellite companies. With the increasing number of satellites in operation, the volume of data generated will be immense. Companies will need to invest in advanced analytics platforms to process and derive insights from this data. This trend will lead to a diversification of services offered by satellite companies, moving beyond traditional imaging and communication to include data-centric services like Earth observation analysis, climate monitoring, and agricultural insights. The ability to provide actionable intelligence will become a key differentiator in a crowded market. Conclusion: the future of private satellite companies is poised for remarkable transformation. Influenced by technological advancements, competitive dynamics, and the broader demand for space-based services. As companies navigate this evolving landscape, those that prioritize innovation, sustainability, and collaboration will be well-positioned to thrive in the burgeoning space economy. The coming years will not only reshape satellite operations but also redefine humanity's relationship with space, unlocking opportunities previously deemed unimaginable.